Hey everybody, Nick Espinosa, your chief security fanatic here. Don't forget to subscribe. And today, I want to talk about what happens in a trillionth of a second. And also, why it's going to shape our future. This is super interesting, and Raul Limon of El País had a really good write-up on this. And if you think about it, we have all basically had that feeling that everything happens very quickly, right? Some things you blink and boom, it's done, right? But normal things in our everyday lives happen insanely slow compared to the speed of events in the microscopic world. Now, the microscopic world is essentially beyond the limits of our perception, human perception, where matter is determined, where combinations of particles make up substances, and basically the universe, right? The particles make up the substances that make the universe. And there are events that occur in attoseconds. That means 1/trillionth of a second. Now, if you're not sure what that is, think about this. If I say 1 Alabama, that's 1 second. But an attosecond is equivalent to, and I've got it written out here, 0.000000000000000000001. That is basically 0.01 second, and it corresponds approximately to the time it takes light to pass through an atom and the natural scale of the electronic motion in matter. Now, the Institute of Photonic Sciences has also achieved what is called a soft X-ray pulse of just 19.2 attoseconds. And we're talking, again, 0.00000, so many zeros. Now, this was an interesting article in El País, but I wanted to really dive into this and talk about the ramifications that this has for our future. We may not think about it, but this is actually shaping, eventually, our future technology, our society, and so much more. So let's talk about why this matters scientifically. Now, if you didn't know, electrons determine virtually all physical and chemical behavior, from how materials carry electricity to how chemical reactions unfold, and on and on and on. But before attosecond tools, researchers could only infer these processes indirectly because electron motion is too fast to measure using traditional techniques. Directly observing electrons enables scientists to answer foundational questions in things like atomic physics, quantum materials, where, electron interactions are incredibly complex, chemical reaction dynamics, ultra-fast energy transfer processes, and essentially this level of insight was only previously theoretical until recently. That's how new this is. It's so interesting. And although basically this is still largely in the research phase, attosecond technology can have concrete, real transformative impacts into several domains. And again, I went and did my homework on this. And the first one I think is interesting is energy technology and transmission. Now, significant electrical energy is lost, about 10% or so, in power grids due to inefficiencies at the material level. So by measuring how electrons can move and scatter in conductors, researchers could identify materials with lower resistance or dissipation. They could optimize conductor properties to reduce loss. They could even discover new materials with exceptionally low energy dissipation. In other words, that 10% loss goes way down, right? There is practical impact to that, right? More efficient power grids, reduced waste heat, lower carbon emissions, improved energy sustainability. It's awesome. On top of that, we have semiconductors and microprocessors. The problem we have today is that device speeds are limited by how fast electrons can respond to electric fields. Conventional design, for the record, often treats electrons as independent, but we're learning they're not necessarily that. So this kind of technology helps by giving basically data to refine semiconductor physics models. This could lead to materials or transistor designs with much faster switching speeds, and on and on and on. And there is practical impact here. We're talking faster processors, improved low power logic, enhanced performance in computing and mobile devices, and more. It's literally like next generation. It's awesome. On top of it, quantum technologies and computation are directly impacted by this as well. Connections to quantum technology at the electron level are so unbelievably tight. Electron interactions are fundamental to quantum behavior. But But better knowledge of these, basically these dynamics, supports design of quantum materials with specific electron correlation properties, also the development of quantum sensing or memory components based on controlled electron states. And there are so many possible outcomes here. I mean, think about more reliable quantum bits or qubits, improved quantum device performance, new quantum sensor applications. In other words, quantum computing, which is one of the hot things outside of artificial intelligence, is going to become faster, better, more reliable, all of these things. And there's so many more fields that I was reading about, like from materials and designs to creation of new materials, neuromorphic computing as well, more accurate healthcare. Like think about all the scans that we get where we're bombarding ourselves. They could be hyper accurate compared to where they are today. So this is, I think, really transformational. And although these technologies are not yet mainstream commercial products, they open foundational capabilities that could change how materials and devices are engineered. So some of the other examples I could find are things like ultra-fast spectroscopy tools for chemistry and material science, next-generation microprocessor design, leveraging detailed electron motion data, new classes of functional material created by controlling electron interactions, advanced imaging systems that reveal processes inside our own living cells in real time. All of these rely on the ability to observe and manipulate physical processes at timescales previously thought inaccessible. In other words, this microscopic technology has huge ramifications for the world. And I think it's something that we really should be looking at, embracing, investing in, and all of that. We should be looking at the forefront of new technologies, not trying to take 2 steps back and fall back on traditional technologies. We can become faster, efficient, cleaner, just make the world a better place. So this is interesting. I hope you found it interesting too. And that is your news of the day. And please like, share, follow me here on Facebook and Twitter at NickAESP. And please feel free to subscribe to me at YouTube as well. And as always, stay safe, stay online, and please, 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 I have to stay private, informed, and secure. Take care.